Hello, and welcome to the X-ray crystallography facility in the chemistry department at Penn. I am Pat Carroll. I'm the director of the facility and have been since 1980. What we do in this facility is use X-rays and crystals and the process of diffraction in order to determine the structure of chemical molecules. Now, these crystals I mentioned are not terribly big. I have one right here on this mounting apparatus, and it's about 0.2 of a millimeter in size, so you probably can't see it from where you are. If I were to give an analogy to explain a little bit about the theory behind X-ray crystallography, I might compare it to an optical microscope. An optical microscope uses visible light. It has one lens that looks at the object and constructs what's called a diffraction pattern. Then the second lens takes that diffraction pattern and reconstructs it to form the enlarged image. We would like to do the same sort of thing. The problem is you can't physically build a lens that will focus X-rays, so we have to use a computer to do the work. It's important to understand that the thing that X-rays are seeing as they go through the crystal is electron density. And that's how we identify and find atoms. Atoms with a lot of electron density might be a heavier element. Atoms with a lower electron density would be a lighter element. The process starts over on the mounting microscope. The reason we have to use this microscope, of course, is these crystals are pretty small, and they are on a glass slide in some thick oil so that we can work with them, and sometimes they have to be cut down to size. But at any rate, they have to be dipped out of the oil and put on the tip of the goniometer head in order to have it fastened for attaching the goniometer head to the instrument. The instrument is called a diffractometer. In fact, we have two of them. There's a second one very similar to this one, hidden back behind that column. I would now mount the goniometer head on the diffractometer. I would have the X-rays take pictures through the crystal, and what I end up with is halfway through that process I mentioned earlier. I end up with a diffraction pattern, and then the computer converts that diffraction pattern into an electron density map. And from the electron density map, we locate the atoms. So we have this nice state-of-the-art software that will allow us to look at the molecule that we have just determined and play around with it and look at the interesting features of it.